the nature and philosophy of dialogue systems from the very first Western system that I'm aware of, Eliza, to a modern system, Eugene. Okay, so firstly, I'd like to say thank you for allowing me to present in English. I feel very guilty. I should have learned at least hello properly in English, so I apologise for that. So thank you very much. And secondly, I don't think I would have been able to give this talk had it not been for fantastic sponsors allowing me a valuable sponsor of the platform, and also to the hard work behind the scenes of these wonderful ladies who've made this a very, very pleasant first trip to Russia. So thank you very much for your kindness and generosity. It's really helped me to feel comfortable. Okay, so the names of the ladies are there. And I also want to say thank you very, very much for all the chocolates. I clicked up the picture. I desperately wanted Russian chocolates for my colleagues, and I was going to buy them, but these lovely ladies brought me 3 big boxes and a big bag, which for half the bag is finished already, obviously not. So apologies to don't tell my colleagues, but I still have the boxes. So thank you very much for that. Okay, so overview of today's talk. I'm just going to quickly outline what I do. I'm at Reading University, so what am I doing there? So I'm going to quickly outline that. I work on an EU-funded RoboLaw project. And then I'm going to, I apologise, I'm going to make you work. This is not going to be me standing here talking for an hour and then half an hour. Sorry, I'm going to make you work. I've got some exercises for you to do. So hopefully it'll be an interactive session. So I'll explain as we go along. And I hope you will enjoy it as much as I will, hopefully. And then I'm going to, this is the first time I'm presenting a new study of comparison of Eliza, Weiss and Brown's 1966 dialogue system with today's best systems that we know of. So this is the first time I'm presenting this outside of my boss at Reading University. So I'll talk about a brief history of Eliza, why compare Eliza with modern systems, the study, the experiment, what the results said, and what is the future of soft bots, soft robots, computer programs, so virtual embodied systems. Okay, so this is the project I work on, RoboLaw. I'm a research fellow, and it's funded by the EU under the Science in Society. This is from the website. So what we look at is robotics facing law and ethics. So we are a 4-university consortium headed by Santa Anna in Pisa, the Biorobotics Institute, so they head the project, and then there are 3 other universities, University of Reading, a university in Germany, and a university in Holland. So on the team we have roboticists, lawyers, philosophers, ethicists, and me, conversation analyst. So, okay, so that's the project. So this is my wonderful boss. No, he truly is a wonderful boss. So in case you don't know, this is on Channel 4, a Paralympic program from last year. So if you don't know who he is, he's the first human cyborg, while the Americans were inserting chips in the brains of macaque monkeys. Duke University, North Carolina, Professor Warwick was chipping himself. He is in the 2013 Guinness Book of Records because his wife was also chipped in an experiment in 2002, and they had the first human-to-human nervous system communication, and you can read all about it. They call him Captain Cyborg, but he showed that thought is an electrical signal down the median nerve, and you can, through thought, control projects outside, artifacts outside of your body. So the main role of University of Reading in the RoboLaw project is to contribute to research, write reports on the taxonomy of robotics and emerging technology, investigate human enhancement. For example, there is an artist called Neil Harbison who was colorblind. He had a computer chip installed in the back of his head, which is connected to a device which sits on his forehead. Now, the British UK Home Office would not allow him to have a photograph with the eyeball device. But he took them to court and explained, that is me. That device allows me to see colour, perceive colour. So he won, he has that device. So human enhancement, if it's to restore a function or give a function that a human never had, I don't see any problem with it. So this is the kind of thing we consider. So it's the ethical, legal and social implications of human enhancement, so which also then means rethinking what is normal human capacity and what is impairment. And we also will, at the end of the project, submit a huge white paper giving recommendations on law, rights, human rights, robot rights in a world of emerging technologies. So the kind of things, the reason why University of Reading was brought into the project is because of the research that is, some of the research that is being done there. For example, looking at the strategies of drones, and I'm sure you're all aware of like the issues like collateral damage from the murder, well, I'll call it murder because it's in my country, Pakistan, of children and women through drone use, but then there's also privacy issues in the use of drones in civilian areas which are being used, so for example in America, so are they spying on us? What's happening? So that's one of the research projects at Reading. This is Professor Warwick on BBC discussing the issue about drones with Professor Noel Sharkey, another famous professor of robotics. Another project of University of Reading is the Hector robot, companion to the elderly who live alone in their own home. What Hector does is like a diary management. It reminds the elderly person when to take medicine. If the elderly person falls, the Hector has a vision recognition and language. It's able to call emergency services to get help. So this is another project, another reason why Reading was brought in. But of course other universities and other institutes are working too. For example, this young boy, he's born without hands, so he has a device which helps him. This is not Reading University, but this is the kind of things that we have a look. Is it fair if he beats a young golfer who has the two, if he's better? Is this device an unfair tool if he beats other children? So these are the kind of things we look at. This person who's blinded in the war, and this brain port device, it's like a lollipop, you put it on your tongue, it's connected to the brain, it allows him to perceive objects so he doesn't bang into them, he doesn't hurt himself. So again, these are the kind of things. Assist for the elderly to give them better mobility, this is Honda's project. Then there's the exoskeletons. This is a lady who, she's paralyzed, but the exoskeleton allowed her to walk the marathon, London Marathon last year. So exoskeletons allowing people, humans, to hopefully live as normal a life and have the mobility to allow them to do what they want to. So this all leads to, we have to rethink, what does it mean, normal human, disabled human? For example, if you look at the Olympics last year, fully able-bodied, Usain Bolt ran 100 meters in 9.63 seconds. The Smythe up there, he has only 10% vision, and he ran it in 10.46 seconds. Johnny Peacock has single amputee. He ran the same 100 meters in the Paralympics in 10.9 seconds. What happens when the blade becomes so sophisticated and advanced that the single and double amputees run faster than the able-bodied? And say the able-bodied say, we still want to compete and come first, and we want our legs chopped off, or we want blades. These are things we have to consider because people may really want to do that. For example, when people are unwell and they don't want to live, they want to die. There's court cases in England taking place right now where people want to choose to die. So if you want to choose to die, maybe you want to choose to have a faster leg or a better eye or whatever. Okay, so these are the kind of things that we are considering in the RoboLaw project. Okay, so I hope that just gives you a kind of idea of what we're doing. Okay, now this is the time to wake you all up. Please, under your chairs, you will find a sheet of paper. Please would you look at the one which says transcript 1. What I'm asking you to do is to read where it says transcript 1. I want you to read that conversation. This is a real conversation that has taken place. I'd like you, I can tell you that the judge interrogator is human. I'd like you to tell me what you think the entity is. So I'll just give you a couple of minutes to have a quick read. Tell me, is the entity human or machine? It's on the sheet with me. If I talk too fast, please tell me to slow down. Okay. Or if you do not understand, sorry. No, I'm not asking you to compare. Just read transcript 1 first. Sorry, I'll explain that quickly. Please, at the moment, just read transcript 1, and I just want you to tell me what you think the entity is. The judge interrogator is definitely human, but what do you think the entity is? For those of the late arrivals, you will find the sheet under your chair. So, under your chair, there will be a sheet. Please read transcript 1. Thank you. Okay, would you now please turn over and have a look at transcript 2. It's the same judge, the judge is human. What is the entity in this case? Is entity in transcript 2, are they human or machine? Okay. Anybody need more time to say? Okay. Yeah, but I just tabled it like that. You've had 2 conversations, transcript 1, transcript 2. Did you determine correctly? Okay, transcript 1. Is anybody brave enough to say what they think the entity is? Human, yes. Number 1. Okay, those of you who think entity 1, transcript 1 is human, please put your hand up. Okay, anybody think differently? Okay, what do you say it is? Machine? So transcript 1 is machine. Okay, okay, let's now talk about transcript 2. Please put your hand up, transcript 2, if you think it's human. Okay, if you think it's machine, I'm going to tell you the answer, don't worry, I'm going to tell you. Okay, this is the answer. The left entity was a human English-speaking male, left entity, right entity was a machine. So this transcript 2, the judge was speaking to a machine. Transcript 1, the judge was speaking to a human. So, but please, for those of you who did not determine correctly, it is difficult. First, I didn't give you a long time. And also, we all have our own subjective opinion of what constitutes a human-like conversation. You know, we all have that. So thank you very much for taking part in that experiment. And so that is kind of what we're looking at. What is the difference between natural and artificial language? Okay. So this leads me now to the whole point of my being here is to present these results. You're the first audience who are seeing this very simple study, so thank you very much for this platform. So, what is Eliza? Eliza was developed by American computer scientist Joseph Weizenbaum, 1966. He was investigating natural language understanding. So he wrote this computer program that imitates a psychotherapist based on the Rogerian paradigm. And here we have a web-based version of Eliza that I used in my study. So basically, Eliza was developed to interact by text only, and that idea comes from somebody called Alan Turing, who advocated fair play for the machines in something called the imitation game, commonly known as the Turing test, where you strip away voice, you strip away smell, touch, look, you just interact through text, and this is pre-internet. So this is an idea of Alan Turing from the late 1940s, following his work at Bletchley Park code breaking in the Second World War. So his idea was that you chat with something, you can't see, you can't hear them. If you think you are talking to a human, but it turns out to be a machine, is it fair not to say that it's intelligent? This was his question. So I ask you all, I think it's a very important, simple but brilliant idea. Chat to somebody, and we now do it all the time on the internet. Emails, we receive emails all the time from people we don't know. I'm commonly referred to as Mr. Because from my name you can't tell if I'm male or female. So for those who were expecting a young man today, apologies, I'm a middle-aged Pakistani woman. Sorry about that. But anyway, so Eliza, the 1966 version, had just 200 lines of input code. Yet it could allow a conversation for many minutes. People could talk to it for quite a long time. So I'm not going to go into the technology because I'm not a technologist, but basically it had a ranking number, so based on pronouns and nouns and how it worked, and I'm sure most of you have seen how it works. So basically it responded like a psychotherapist. That meant that it asked questions of the patient. That's what psychotherapists do, ask questions and try to get the patient to talk about themselves, to try and work out what is their problem. Okay, so I now have another transcript that I just want you to quickly look at. So if we may pass it round, would you please pass this? Thank you. Thank you. Once you receive the sheet, please would you look at the side of the sheet which has the Eliza dialogue. So you'll be looking at something like that. I'm just giving you this to keep so you can see what Eliza is in capitals. And Eliza is talking to a human. So that's another real conversation which I just took off the web, but that's a real conversation. So this kind of illustrates how Eliza works. If you look at how it works, Eliza is not giving any personal information about itself. It keeps asking questions. Yeah? So that's how Eliza worked. Okay? So this is just okay. The same what you have there. So that gives you an idea of how it works. It's the same conversation that you've got on the sheet of paper. Okay, so Eliza and deception. Even in 1966, even in the 1960s, Eliza, with just 200 lines of code, if you imagine how many words we have in our mental dictionary, and how many sentences we can form, right? It's a lot more than 200, even an average, whatever an average is. Even a child will have more than 200. With just 200 lines of code, Eliza was able to fool people in short conversations. They really thought they were interacting with the psychologist. Obviously, they couldn't see, but just to pretend. They thought they were talking to a psychologist, even back then. Weisenbaum's secretary, she would have believed that, no, there isn't a psychiatrist on the end of this. Obviously, there was the novelty value, because this was the first time that you were able to do this. However, the secretary said, please leave the room, and she wanted to talk to the computer program. She really thought it was a psychologist. Okay, so talking to Eliza, some people showed more emotion, they were more open with Eliza than they were when speaking to humans. So that means some people prefer talking to machines than humans. But, you know, everybody is different. Then we move on to the 1970s, taking that concept of interacting by text. Psychiatrist Kenneth Colby developed a program called Parry, and it was a computer model of a patient who suffers from paranoid schizophrenia. So they did a series of tests with human psychiatrists as judges. They showed them the conversations. So they had one set of psychiatrists who talked to Parry and a real patient. A second set of psychiatrists then looked at the conversations. The second set of psychiatrists, only 50-50 it was guessing which was the real patient and which was the computer program. So in other words, it was developed to show it's a very single domain, you know, like paranoia, but in that single domain, the computer program Parry was able to deceive psychiatrists. They weren't sure whether they were reading the ideas, the concepts, whatever, of real human or a real patient. Okay, so fast forward to 2008, so that's kind of just tracing the history of dialogue systems. In 2008, at Reading University, we conducted a big Turing test contest, and one of the judges, when he spoke to a system, this is what he said. So if you look, you've got the dialogue of Eliza, but this is what one of the judges, he was astounded that the machine could remember a question and give the right answer. If you look at what Eliza was doing, Eliza couldn't do that. All Eliza did was ask questions. But this program, he said it was a great achievement. In that contest, that program, Eugene came second. And so this was a judge, the judge was an American psychologist as well, and this is what he said. Okay, Eugene performance. Another person who was deceived by the program was a UK newspaper called The Times. One of the journalists, he really thought he was talking to a human when he was chatting to an artificial dialogue system. So much so that when he was talking also to a human at the same time, who happened to be non-native English speaker, French lady, he thought that French lady was a machine. No kidding. He was so confused. He wrote a big article in the Times newspaper about his confusion. He said, I can't tell anymore. When I go to a machine where it has drinks, is that a human? Or I thought, well, I can't tell robot from human anymore. So if anybody's interested, I can send them the link to that Times newspaper article. So that was in 2008, the performance. So what I'm trying to show is the progress since Eliza, 1966. So you all know this gentleman, Vladimir Veslov. He is behind Eugene. He's holding a trophy. His system won the massive, huge Turing test contest last year that University of Reading organised at a place called Bletchley Park, where the British conducted their code breaking during the Second World War. He's also behind the team who developed Spoonie character, the competitor to Siri. So the trophy that he is holding, that was given by a hotel called the Colonnade Hotel London, Mirabelle, behind Paddington. That Alan Turing was born. When he was born, it was called the Paddington Lodge. It's now the Colonnade Hotel. So they paid for that trophy. So it was a unique trophy that Vladimir won. He was very pleased, and we were pleased for him. He deserved it. Okay, so dialogue agents now used in e-commerce. In the middle you have the American dialogue system, Sergeant Star. On each side of it you have English dialogue agents. You have O2, which is a mobile provider. The lady cleaning her glasses is Sky, which runs TV channels in the UK. Up there in the green you have Asda, which is like, I don't know what is the equivalent, Walmart's or something, huge store, and then IKEA's Anna. Okay, so Sergeant Star, I had a conversation with Sergeant Star, so if anybody wants to read it later on, I'm quite happy to show them. It's funded by the US Army, so it's quite amusing talking to it. And then one journalist put Sergeant Star together with IKEA's Anna. It's a very amusing conversation if anybody wants to if anybody's read it, so it's quite amusing. So, so there's the link to the conversation. And, we might think it's funny, but Turing said that in the future, the machines will talk to themselves to sharpen the wits, and we humans will be left behind because the machines will be more intellectual. We will have to run to keep up with their intellect. This is what Turing said in 1951. Okay, so what are the advantages of dialogue systems in e-commerce? Like we were talking last night about what is the commercial use. Everything is commercial. There's got to be some money involved in it or money from it. So this is the advantage. This is in a personal email to me from one of the company directors, Chris Ezekiel from Creative Virtual. This is what he said to me in 2005. Using these dialogue agents in e-commerce, so they augment, they add to the keyword function on websites. So when you go to a website, rather than just do a keyword search, having a character, people prefer, they're more satisfied when they have a character and they can ask, for example, if you go to IKEA and speak to Anna, you can say, Anna, I'm looking for long bathroom mirror. So you can actually converse with it rather than going to the keyword. So Chris Ezekiel said, customer satisfaction up. This was on IKEA's Anna. The call centre workload, so obviously that means human people are being reduced. The call centres, less staff. Return on investment, that's way up 200%. So the cost of the system is more than sorted out by its use, because you can reduce staff in call centres, which is bad for humans, we're losing jobs. But anyway, so there's the commercial advantages of using dialogue systems. So why bother comparing Eliza with modern systems? Why did we bother? Okay, I wanted to do it to challenge a claim. There was a claim made after the 2008 Turing test at Reading University, and I won't be mean about the person. Well, actually, I might be mean. But anyway, Florida, a philosopher, there are always philosophers, aren't they, complaining and all this. So this philosopher, Luciano Floridi, and his PhD students wrote a comment, 2008, the dialogue system, they're just like Eliza, they're the same old techniques. I thought, on what basis is he making that statement? He actually, and his PhD students, took part in the 2008 Reading Turing test contest. So I decided to look at their results. Why are they saying that? Let me look at the conversation. And what I actually found was, there's no basis for their claim. In fact, they were very poor at determining human from machine. Their correct recognition rate was only 56%. So they couldn't tell human from machine. So how can they say that the machines are using the same old Elizas when they thought the machines were human? So there was no basis. So correct recognition. So that's why I thought, well, okay, it's no use just saying, okay, we've checked Floridi's conversations and they were correct. Let's do a quick study. So we did a quick study using, this is Alan Turing's one-to-one test, which is the Viva Voce. So in other words, it's one-to-one direct. So you can't see, you can't hear. On one side there's a human, on the other side there's something you can't see, can't hear, smell, touch when you try and determine. So we decided to use that. He also has another test, but I won't complicate by talking about the other one. So just wrote a quick guidelines to set up a study to compare. Basically, the Viva Voce Turing's test emerged from a chess game. If you look at an essay Turing wrote in 1948, Intelligent Machinery, he devised a game called chess. And if you think what happened in 1997, man versus machine, Turing predicted that it could be done back in the 1940s. The 1997 machine did beat humans at chess. But Turing evolved the chess game into a language conversation game. So by 1950, Turing's test had evolved from chess to conversation. So we used his idea for this experiment, Turing 100 in 2012. Last year was the 100th anniversary of Alan Turing's birth. So there were international celebrations all around the world, from Brazil to India, China, Israel, everywhere. There were, I'm sure there were in Russia too. So Reading University also staged 2 events. One was a huge one-day experiment public at Bletchley Park on the birthday of Alan Turing, 23rd of June. The second was the all-year-round 2012 Eliza comparison. Okay, so arranging the study, internet-based. Most of today's dialogue systems, like Eugene, Cleverbot, they already have houses, URLs on the internet, so it's quite easy. They were already on the internet, so we could have an internet-based study. So we persuaded the best current developers, like Vladimir, of Eugene Gooseman and Rollo Carpenter of Cleverbot and some of the others. We asked them to participate. We asked them, you already have your systems on the web. Can you put an anonymous URL so it doesn't say Cleverbot? Can you have anonymous ones so that we can use them for the study? And they kindly agreed. And they agreed to let their anonymous websites available all from January to December 2012. So then we recruited judges. We just used Twitter, we used Facebook, we used LinkedIn, British Computer Society's Computing at School forum. So we recruited teachers. So we recruited like lots and lots of people. And what we did, we asked them, firstly, these the hidden dialogists. What we did, so we had 6 entities. One was Eliza, and the others, so the judges wouldn't know whether it's human or machine. We gave them an identity number. So Eliza, we told the judges that it's a machine, but the others, those were the websites, and we just said, you will be speaking to 6 entities. E1 is a machine, the others, it's up to you. And they're identified as E612, blah, blah, blah. Those numbers, we chose those numbers because they relate to Alan Turing. So 6, he was born in the 6th month. 12, he was born in 1912, 20th century. 23, we chose that was his birthday, 23rd of June. And 41, sadly, is the age when he committed suicide in 1954. So it's a bit sad. But anyway, so that's where those identity numbers came from. Okay, the judges then. So the human judges, we had males, females, school pupils, university students, members of the public answering calls. They were English speakers. We also had non-native English speakers. And after English, the next large number of judges were Spanish speaking from a university in Barcelona and a university in China, but we also had Russian speakers, especially children at private schools in London who spoke Russian as well. The age range was 13 to 64. Okay, so what did the judges have to do? We asked them to complete a short questionnaire. We wanted some information like, are you male, female, what is your age range? So some questions. We asked them to chat to 6 entities on internet websites for at least 5 minutes each. 5 minutes was the time because that's the time Turing mentioned in his 1950 paper, Computing, Machinery and Intelligence. The judges were informed that 1 is definitely machine. Eliza, the identity is E1. Now, for the other entities, we didn't want to say, can you guess if it's human or machine? We asked them to give conversational ability score for Eliza and the systems. And we asked them, after you chat, each system, can you give a score of conversational ability, your personal opinion, from 0 to 100, where 50 is a good conversationalist, 100, but it's still a machine, and 100 means, oh, this is, I think it's human-like. But we wanted a score rather than, say, human or machine. And we asked the judges to return questionnaire and score sheet. As happens, you can get thousands of judges, but not everybody. They all love having a chat, but not everybody will return. So we only received back 118 from thousands, but still 118 is better than nothing. So this was the questionnaire, so asking some questions. I have a copy of it if anybody wants to have a look at it later on. So the human judges, this is just some information about the judges. So 118 returned. We know there were more, thousands, because the whole schools, we had whole schools taking part, but they didn't return the questionnaires. We had more males, 72. So that's basically, I don't want to waste time reading it out. So basically, more males. The age range, there were more aged 19 and above. We asked them if they had English as their first language. We asked them if they used social media, because we wanted to know how internet savvy the judges were. We also asked them some things about privacy, because there's issues of cybercrime. So we asked some questions about how good they are at protecting themselves on the internet. For example, do they use the same password across their different internet channels like banks, emails? And we were surprised, so many. Look, 32 of the 180 use the same password for everything. So in a way, we were raising awareness that you really ought not to do that. And we asked them if they'd heard of campaigns to protect. So this was just a little bit extra, because cybercrime is a really big issue for the UK government. They've identified it as one of the 4 major threats to their economy over the next 5 years. Okay, so this was the judge score sheet. So basically, it was sent out. We asked them to be courteous, to be polite, because the conversations would be recorded by the developers. So if anybody was rude, they would cut the judge off. So we asked them to be courteous, treat you don't know who you're talking to. It could be a child. Treat it as you would a stranger. So be courteous. Talk to it for at least 5 minutes, and then return scores. So we asked them to give a score, say whether they felt there were any emotional content in the answers, and any other comments. So that was the score sheet with the web pages. Okay, so this is the entity scores. Okay, so entity 1, Eliza, I thought it would get 0, but the average score, conversation score, was 25.78%. Somebody gave it full marks. Eliza got full marks, but 100 out of 100. But the best systems were Cleverbot and Eugene, which got over 60%, which is considered good conversation. So those were the scores that we received. Now, what's going on with Eliza getting such a... okay, so this is a quick graph of how it looks. So these are E1, E6, E12, E19, E23, E41. So this is how it looks in a graph. Once you can see, it's quite impressive with Cleverbot and Eugene, conversation ability. So Eliza feedback. We were quite surprised. We thought Eliza would get 0 because, but its average score was 26%, which, as defined by our study, means it's halfway to being a good conversationalist. We looked at who was the judge that gave 100 marks. It was a Chinese speaker. So maybe, see, this is why we asked some information from the judges. So they were aged 19 to 24. They were based in China, at a university in China. So maybe English is not their main language. So they were, I don't know what happened, but they gave Eliza more than the other systems. They gave 10% for E6, ultra health, 10% for E12, Lbot, 65% for Cleverbot, E19, 51% for Eugene, E23, and 40% for E1, E41. So that particular judge preferred Eliza. See, subjective. So scores themselves then, really they don't tell us much. What is more helpful, I apologise, I know it's your time, so I'll go quickly. What is more helpful are the comments. You know what the judges actually say. It's okay to have the scores, but it was also helpful to have their comments. So overall comments. Now this is a gentleman who answered the call for participation from LinkedIn. We did a call on LinkedIn, so he's a computer programmer, speaks Serbian, Russian, Bulgarian, and I have full analysis if anybody wants to read it. And he thought that sometimes it was a human. No, if you want to read more, I've got his full comments. He gave extensive comments which were very helpful. So if you now, the Eliza sheet that you have, if you turn over, you'll see another conversation. I'd like to have a quick look at it, because there you've got the comparison, and on one side is Eliza, the other side you have Eugene. So I'd like you to have a look, because it is impressive if you have a look. So in this case, the user was a Spanish student, University of Barcelona, and her feedback, she really enjoyed speaking to this system. And if you look at the kind of questions, she really thought it was a human. She gave it good marks. And if you then compare with the kind of responses Eliza had on the sheet on the other side, and then look at Eugene, you can see that there is progress in the way machines speak. Okay, so it's not like as good as a 5-year-old human child. It's still better at conversation, but we're getting there slowly. We're getting there. So anybody not impressed with Eugene? Anybody think so what? Okay, so what is the strategy then of these dialogue systems? Like Eliza, they take hold of the conversation, so they direct the conversation. They are leading the conversation. So they will ask. So if you look at what Eugene was doing, it's still like Eliza asking the questions, saying like, where are you from? Could you tell me about your job? So it's still getting the human to talk about themselves. And they're giving the illusion of following the conversation. Where if you look at Eliza, you could say that yes, Eliza was following the conversation, but you could confuse Eliza by saying, Eliza, how do you feel? Then it would go into a repetitive loop and it would crash. The current systems don't do that. You can ask questions like, how do you feel, Eugene? How do you feel, Cleverbot? And I was speaking to a lady yesterday who knows Cleverbot. I don't know if she's here today, and she said, yeah, well, she knows Cleverbot very well. So they can share personal information. So Eliza couldn't do that, but now they do. For example, the user, human, said, what kind of music do you like? The bot, Eugene, said, I like the very talented Russian singer Alla Micheva. So in other words, this Eugene Guzman has interests, has personal interests. So which Eliza did not have. Okay? Whether it's true or not, whether the bot really, we obviously know it doesn't, but the human user was impressed. Hey, this bot knows that a rap singer. So, is it the same old technique then? Are the current systems using the same technique as Eliza? In a way, you could say they are, because they are asking questions, but that's what humans do. When I was with emails with Tatiana Frekin, what are we doing? Asking questions. That's what humans do. So if modern dialogue systems are using the same old strategy of Eliza, of asking questions, that's because that's what we humans do. This is how we get to know each other. We ask questions. We have interest. We want to become acquainted. So we ask questions and we listen. Yes? So, yes, it is using the same old strategy. The modern systems are, yes, using the same old strategies of Eliza, but that's because that's what we humans do as well. So it's human-like. It's not machine-like to ask questions. So modern dialogue systems, they are doing it better than Eliza. This is one of the teachers who took part in the study. This is what he said, what his students enjoyed. They were driven to distraction by Eliza, but by the modern systems, they were really quite surprised at how advanced they were. They really enjoyed talking to the best systems, Cleverbot and Eugene. So this is important feedback. So this counters the claim of philosophers who say, oh yeah, but they're not as good as human. Which human? Maybe not like a philosopher, but anyway. Are there any philosophers here? Apologies. Okay, so the systems then. As you can imagine, the developers, they're going to hide their technology because a lot of them are not commercial, so I can't give you the technological architecture of these systems because obviously then it's their intellectual property. What I can say is very different techniques to Eliza. It's not just 200 inputs, it's like millions. And I've got some data if anybody wants to ask me about it. So, yes, sorry, so that was Ultra HAL. And if anybody saw the movie Prometheus last year, Prometheus, you know there's a computer, fantastic movie, I love it. There's a computer on board. Well, they had a Prometheus event in London, a live. They use Ultra HAL for the computer dialogue. So these systems, they're not just, they are being used in entertainment, education. So that's Ultra HAL. LBOT, this won the 2008 Reading University Turing Test contest. A quarter of the judges thought they were talking to a human, but it was LBOT. Even though LBOT does not pretend to be human, it admits it's a robot, but the judges thought it was a double bluff, that it was a human pretending to be a robot, but no, it was a robot. But they were really, the developer, Fred Elbot, is from the company Artificial Solutions. So this is the commercial research development arm of a commercial company called Artificial Solutions. And so he's a computer programmer and a psychologist. So Cleverbot, I know there are people here who've heard of Cleverbot, and it drives people to distraction. So that's the website, and there's so much information on the website about Cleverbot. And if anybody wants to ask me any information about it, I'm quite happy to. Eugene Gooseman, this fooled nearly 1/3 of the judges last year at Bletchley Park. Which was a historic day because it was Alan Turing's 100th birthday. 1/3 of the judges were fooled. They thought it was a human child, but in fact it's a computer program, because the personality of Eugene is based on the 11-year-old Ukrainian child. So the judges thought they really were speaking to a child who is of Ukrainian descent, who has English as second language. I think that's pretty impressive. So this is the last one, Turing Hub. This won Turing Test contest in 1998 and 1999. So all the systems, apart from Eliza, they're all award winners. They are the best developers of these Turing Test systems in the world. Okay, so the study review. So this. So actually, I was comparing the incomparable. Really shouldn't, because Eliza is a single domain, it has one purpose. It's acting like a psychotherapist. All the other systems are general conversations. So in a way, what I did is not, because you can't really compare the two different things. One has a single purpose to talk like a psychotherapist. The others, they can talk on any subject. Also, Eliza is polite. And for those of you who've spoken to systems like Cleverbot, it can be really offensive. So there's a difference there. Eliza has a limited number of responses, just 200 input, output. Some of them, Cleverbot, they have millions, ultra millions. Emotionless, Eliza was emotionless. It was not developed to convey its emotion. Whereas the modern systems, they give an illusion of emotion and therefore understanding, because they're able to share. For example, you can ask Eugene, where did you go to school? And it will tell you its experience. You ask it, where do you live? It'll say, I live next door to my auntie who's an accountant. So it's got a personality. So it gives an illusion of emotion and understanding. So again, they're incomparables. But of course, doing the study made me learn that. Had I not done it, I wouldn't have been able to find that out. So the analysis then is, I still maintain that Florida et al., the philosophers, they're wrong. Yes, because of the systems might not be like as good as a human philosopher language. Let's face it, language is their business. Like a lawyer, philosopher, language is their business. So yeah, they're not as good as, but they are an improvement on Eliza. They are not the same old Eliza. However, we mustn't sit on our laurels and say, yeah, they're better than Eliza. No, there's still a long way to go, because machines can't analogize, and I picked up an analogy that you will all recognize, and they can't create metaphors. Human language, human conversation is full of us analogizing and creating metaphors. Machines can't do that yet. That's a very sophisticated level of language that we need to look at to make machines better. So yeah, there's a long way to go. Also, in this area, there is slow progress, because there is a very bad opinion of the Turing test. And I'm always, wherever I go, I argue Hayes and for Kenneth Hayes and Patrick Hayes and Kenneth Ford. They have a very bad view of the Turing test. So we find it very difficult to get funding to develop systems at universities. So a lot of these systems have been developed by, they were amateurs, and then they made themselves commercial companies like UltraHal, Cleverbot, and because in academia we can't get funding for Turing tests or to build chatbots. This area is not, natural language processing is a big area, yes, but funding is for a specific, which is like end, commercial end, can it be used, like the Siri system. But just to research it and build, there's very little funding. We can't find funding. The Eliza study, I did it in my own time. I didn't get paid for it. Neither did the developers. We just did it in our own time. So what are the possibilities then? Well, look at what IBM Watson achieved 2 years ago. Reverse question answer. It was able to beat 2 human general knowledge contestants. And it was, some people say it wasn't fair because it could press the button quicker, but that's not the case, because they had a time delay on the button pressing, because it was a quiz, a TV quiz show. But if you look at the way Watson worked, deep learning, and it was searching through, it's got like 3 million books in its computer database, and to have to search that and bring out the right answer, I think it's an impressive achievement. So that's IBM Watson, that's with the rings, they move when it's thinking, it's like. So basically the answer is yes, modern systems are better than Eliza. We have a long way to go. Even Watson, all it can do is that specific one task, which is reverse question answer. It cannot analogize, it can't create metaphors, it doesn't understand metonymy and all these other sophisticated and technical linguistic features. So we have a long way to go. The future, what I see is, if anybody's read Neil Stephenson's book, Snow Crash, the main person is called hero protagonist. He has at his disposal, whenever he needs information, he can put glasses on and he logs in, and he has at his disposal a virtual librarian who can bring him who can answer any questions he has. So I suggest it's a fantastic book. His next book was called Cryptonomicon, which is about Turing and code breaking, and that is being made into a Hollywood movie. So anyway, what I see is that we will have, like Siri, like Snoopy, we will all have our own personal, whether it's on our watches, whether it's in our glasses, whether it's in our shoes, our belts, whatever, we will all have a personal assistant, virtual personal assistant, who can help us to get the information quickly when we need it. So that is definitely, I was saying this in 2005, before Siri. and now we have Siri, Snoopy, and so much. So we will have the mother of all libraries, all of us, at our fingertips, at our idea level. We will have, because it could be in glass, we might have a computer chip installed, like my supervisor had twice, but the future is we will all have information when we need it, for whatever we need it, when we want it. So that is going to happen. We will have these, we might even have personal robots. I can't wait to have a personal robot, to do my Uber cleaning at home, why not? So basically, to finish, I just want to let you know, sorry, just a big plug, my chapter in a new book which is coming out, I think it's coming out very soon. It was delayed, it should have come out last year, anniversary of Alan Turing, but it will be out, I think, in end of this month or June, July. So I have a chapter in part 3, and it talks about, it's more about the Turing's imitation game, if anybody's interested. So there's references that I've peppered through the slides, so I'm quite happy. This presentation, you can all have it, it's not a problem. And so lastly, acknowledgements. Okay. Thank you.
I have some kind of general question on what is artificial intelligence is. Is it this development of chatbots, is it somehow improve our awareness of artificial intelligence, or is it like say contained task? And is it really some area of research, or is it like set of tasks? Because as you said, even Watson, he cannot do that, and even with web chats cannot do what he did, and cannot play chess, and cannot recognize images, and so on. And you have demonstrated a lot of robots here, a lot of examples. But do you think they are really connected somehow, or is it just separate tasks for separate people?
Okay. As I see it, as Turing said in 1950, I don't like definitions, because if you get a definition, you get in a circle. I don't know if you've ever heard that Plato's dialogue, where there's generals, a person goes to generals and say, should we send our child to an army school so it gets courage, or to a normal school? And the person said, what is courage? Courage is bravery. What is bravery? Do you understand what's going on? So if you start to put a definition, you start like that. So artificial intelligence, I guess the goal of artificial intelligence, what I see personal, nothing to do with other people, is that we build systems to improve our life, to make human life better, even if it means having a robot companion for our elder age, so it can help us. I think that's good. Why is language important? Well, Turing said himself in 1951, he said, of all the things that humans can do, like mathematics, playing chess, language, learning language, is the most impressive. That's why he evolved his game from chess to conversation, because he said, look at how children, how from babbling baby to adult, bathed in language. So he felt language was the most impressive of human things that we acquire. Learning and building a machine to have language will help us to understand how it is we learn language, how the brain works. This is what he said. Building, it's an engineering challenge, building a machine to think. He was saying think, but how do we show we're thinking? Because we say what we think, because we talk. So he said, building a machine to think will help us to understand the human brain.
Yes, it was his original idea. Yeah. But after all these years of research, we can see that one machine speaks and other machine think.
Right.
Is it somehow connected?
The thing is, right, if there is the funding, we can bring together research in vision, research in we already have robots that move like humans. We bring together engineering, vision, language, olfaction. There's already machines that recognise more smells than humans. If we bring it together, if there is a will, if somebody wants to do it, yes, we could. But like everywhere else, money is short in research. So rather than building a human like a robot, look at smaller tasks. This is how humans do. You have a big task. I have a big task. To come here to Russia, give a presentation. First of all, I have to do the study, prepare the presentation, fly. You understand? Everything is broken down. So artificial intelligence is split, divided. The problem was that there was big hype after the Second World War. We will be able to do this within, for example, in 1958, Newell and Simon said, within 10 years, we will have a machine that will beat a grandmaster at chess. Okay, so 10 years, it didn't happen in 10 years, but it did happen in 1997. And when Turing was asked, a lot of people said Turing made a mistake because he said we will have a machine that thinks at the end of the 20th century. If you look at Turing's writing, in 1952, in a BBC radio broadcast, he said at least 100 years. So he knew the task is massive. And he actually advocated, that look at the way a child learns. How does it learn? It has parent teaching it, so it's getting what he called interference and imitation, so it learns by imitation. It gets interference, which is education learning. School as well, school teachers. He said, look at the child process of development and then build the robot like that. So he advocated that there's like a collaboration. He said it should be engineered as well as teacher. So see, back then in 1950s, before he died, he was saying collaboration. We'll need a collaboration. That's what we need. And that's why I desperately wanted to come here to Russia to say, please, you want to collaborate with us at Reading University? And so it's hard to get funding, but we do manage somehow. Last year we managed PricewaterhouseCoopers to pay for Turing 100. So we got it. So another reason it's coming is that we would like to collaborate with us at Reading University and say next year's AINL conference, have it at Reading University. Beautiful campus, has hotel there, it's near Heathrow, it's near London. So, with collaboration, we will move faster. We also do not know, as I was mentioning last night to Al, we do not know what technologies really do exist. We only know what we are told and what is for public in universities.
I've got two questions. Thank you very much for the presentation, very interesting. But my question is, do you think that chatbots, where I log in with my, for example, Facebook account, will immediately know everything about me and will be much more human-like than chatbots with anonymous interlocutors? For example, if I log into chatbots with Facebook account, chatbot immediately knows everything about me. Immediately, I'm using my books, my friends, everything. So do you think human-like ability would be higher? And second question, in your list of abilities for chatbots, you put analogy and
metaphor.
Sorry?
Metaphor.
But do you think that we need to put another one is joke?
Yeah, of course, Joe, because that's what humans do. Right, the first question, my Facebook account is not Huma Shah, it's philosophy, spelled with an F. I do not put my age. Why should people know I'm 55? I'm telling you, but I'm not going to tell people on the, but what I'm saying, I don't put my age, my mobile number, where I went to school. It's up to you how much information. Yes, of course, if you put your information, this is one of the worries, because the age group 16 to 24 is the most susceptible to a cybercrime, because they're putting too much where they went to school, where they're having a party, who their friends are, who they're. It's up to you, how much information you put out there. Of course, if you have so much information about where you live, everything on the internet, a chatbot, a developer with a bad intention can copy your information, build a chatbot, and steal your identity. So that's one. Second. Could you repeat the second question?
Jokes.
Of course, we wrote a paper in 2007, something, can a machine tell a joke? Cleverbot tells jokes. telling a joke, being funny, is part of human conversation. It's natural. Can a machine tell a joke? It depends on whether you think it's a joke. So if you chat to a human and they tell you a joke, you might not think it's funny. Like, I was born in Pakistan. So if there is a joke about Kashmir, I'm not going to find it funny. An Indian might find it funny. So do you understand? Culture comes into it. You know, history of social relations comes into it. So can a machine tell a joke? Yes, it can tell a joke. Whether you find it funny or not is up to you. That's your subjective opinion. Whether, you know, it is found funny or not.
Huma, thank you very much for a most interesting presentation.
Welcome.
And could you please provide us some more details from conversation analytic perspective? What features of the dialogues could be perceived by human judges as leading to machine-like evaluation?
Okay. Humans were recognized, those judges who could recognize, because they were able to relate their answer to what was asked. For example, when some judge asked, what is the color of the chair in your room? And they replied with an answer about color or weather. For example, in 2008, the contest, the weather it started off very misty, foggy, and then it came to a beautiful day. The machine can't see the change, so the humans were recognized because the judges asked, what's the weather like? What did you feel about the weather this morning? And the human said, well, it was a bit misty, but it's really lovely now. The machine didn't know that. So it's knowledge, information. The other thing was on the use of emoticons, emotions. So the human, hidden humans, they would use the smiley. But now the chatbots are starting to use the smiley. So it's getting confusing. The other thing was the machine, their answer was always longer than the human. Also, the machine was grammatically correct, whereas the human, when they give answers, spelling mistake, short words, shortened. So there are differences. I can show you. So you can. But the thing is that if you have never chatted to a chatbot before, so for example, when one of the judges, he thought he was talking to a human professor, but it was Lbot. Why did he think that? Because that gave long philosophical answers. Yeah, so he thought he was talking to an English professor, but it was a machine, Lbot. So you see, so it's everybody's opinion, isn't it? What does a professor talk like? Long, boring answers. So apologies if there's any professors here today. So yes, there are clear differences. The machines give longer answers and very quick. Even though in 2012, last year, the machines learned, they did time delay to try and make it human-like, because obviously a human can't type as fast as a machine. So 2008, that was what happened. They gave quick response and long. In 2012, the developers knew, we have to do a bit of time delay now. But they were still answers too long, and they're still grammatically correct. So the judges who were human judges who were confused, they said, it looks like a well-educated adult. But the judges who have chatted, they knew it was grammatically correct and more likely to be a machine.
Did you interview human judges?
Yeah, of course, I've got I have did very well. Have a look at very, very well, because yes, you can have a look at their answers. Yeah, very interesting. Thank you. Oh, sorry.
Thank you very much. Thank you very much for the most interesting presentation as well. I was about to ask something, but I just wanted to follow up on the previous question. The reason why I personally thought that the second transcript belonged to a computer, not a human, was, and it was a computer, right? The second
transcript too. Yes, YouTube.
From the original film.
Yeah, YouTube.
Transcript 1, I was actually not sure, because there was nothing very computerish about it. So that's why I said it was a human. But when I looked at transcript 2, when the judge said, if you look at the very end of the transcript, when the judge said, that's very rude, with a question mark, and it was not a question actually. at least to me, because the previous cue of the entity is, I think you should take some typing lessons, or just type more accurately, and the judge says, that's very rude, it's not a question. They just they put the question mark.
Well, I think that is, meant to say that particular judge was a teenage female, because we had all in, but they were personally offended.
Absolutely,
so
and that's why they put the question mark, because they didn't know how to react.
Yes.
And then the entity goes, frankly, I didn't get your question, and it was not a question. No human would think it was a question. So that's why, that was the red flag for me. That was the computer issue.
Because the computer saw the question mark, but didn't recognise the utterance as a normal question, so you determined that it must be a machine then. But some people took that another way, that it was a non-native English-speaking human. Where they thought, because they are not English, they don't understand. Sometimes you can use a question mark as a rhetorical device. So, so this is the kind of thing, but that's a very valid point.
Yeah, and I also wanted to second the thought of collaboration. I'm now at Iowa State University, and I also invite everybody to our campus. We have a lovely Midwestern campus in Iowa, and I also we would be very interested in collaborating with you and with others, of course. And our university specializes in developing computers. Yeah, certainly.
I'm sorry to interrupt. Let's get back to the questions, and we'll discuss all the collaboration after the lecture. Sorry, we are short of time.
Yeah, absolutely. Sorry.
So actually, that's Lydia's question, but somehow she chose not to ask it. So well, you have 6 entities given to a judge, and then you compare their mean scores. However, you do not have any score for humans. So we wonder if humans could possibly have a score as high as possibly the rest of machine entities. So we do not have a baseline. How to understand?
Okay, I was comparing them with Eliza, not with the humans. So in other words, the study was to compare model systems with Eliza. To have the human, which human would I choose to? So in the Bletchley Park contest, we did have hidden humans. So the judge would sometimes talk to a machine, sometimes not. But this was a comparison of Eliza. To say we don't have a baseline of human life, which human would I choose to say it's 100%? Would I choose that philosopher, Professor Floridi? Do you understand? Which human do you use and say, well, that's 100%, so compare the systems against that human? No. So we weren't saying, I know what you're saying, because you said that I have 100% is human-like. What I was doing is giving the judges some kind of like base for them to, so in their personal opinion, they would give 100 if they thought this is as good as a human conversation. But which human? So it's a very important question. I mean, that is one of the failings of my study. It's not a perfect study, but it is one of the failings. But I was comparing the systems against Eliza. Because then if I would have a hidden, we did do it at the Bletchley Park, sometimes machine, sometimes human. If I did it with the Eliza study, so you've got Eliza, human, then the machine. Which human would I choose? Should I have chosen a psychotherapist? So you've got Eliza, the psychotherapist, and then the systems. Then it gets complicated because those systems are not psychotherapists. That's failings of the system, But it's a very valid point, and we will, like to do it again. Thank you.
Just because I'm not sure that I can get 100 points in that is my partner. Would I personally be better than this?
Well, this is it. It's subjective. What constitutes good conversation is a very subjective opinion. Like, say, if I was talking to the philosopher, Professor Floridi, I'd be like that. Serious argument, 0. But, so it's everybody's opinion. Everybody's different. We are biased. Like my favourite topic, apart from study, is cricket. Unless you are like from English, when English had the empire, and you play cricket, you won't want to talk about cricket. I can't wait for the next month, because in London we're going to have the big ICC Cricket Champions Trophy. I can't talk to you all about it, but if I got a cricket person, I would sit with them for hours. But do you understand, somebody who plays golf might not like cricket. We all have our own different of what is interesting.
That is really an impressive presentation.
Thank you.
So my question is that imaginary, philosophical maybe. When do you think robots will take human to court? And are we going to create some robot laws for robots?
Yeah.
And maybe
that's what
robots' rights. Yes.
That's exactly what we're investigating in the Robo-Law project.
Yes.
Once robots become conscious and self-aware, can the mother of that robot, another robot, take the human to court if the robot makes a mistake and we kill it, like switch it?
Yes.
It sounds like science fiction, but this is going to be science reality. So we are...
I already brought my court by the robot, because recently I got a paper for speeding in Moscow, and it was somebody called Lieutenant Ivanov, and I never saw this Lieutenant Ivanov, and I had no idea who is Lieutenant Ivanov, and it was facsimile, so it's actually a bot.
Okay, it's working.
So,
okay.
So
that's really impressive.
It's like this picture of my car.
Thank you for this good presentation. I have one question about this chatbot. Can they learning something not only in one conversation, but in all conversations? For example, how to take people more long time to conversate or get some information.
They are learning bots. So, for example, these developers have put their systems on Twitter, Facebook. They're learning from human to human conversation, because that tells you how humans talk to each other. So yeah, they are learning bots, and so they are tweaked. The chatbots are tweaked, they're changed to improve, so that they talk more and more human-like. So they will get better. They will get better. So they are learning systems. They have that architecture within them to help them to learn. So they learn how a human says something. Now, different humans say things differently. So it learns from the different ways. So you can say, where is the library? You can ask it that way, or library where? I'd like to find a place of books. Different people say it differently. So yeah, they are learning how, from human to human conversation on the internet, how people say, ask and converse. So, thank you.
Any more questions? Okay, thank you. It's perfect timing.